was about in half. So it was also not in everyone.
Mm-hmm.
So it's an interesting question, but I think it needs we need to look further in those individuals and try to answer these.
Yeah, I asked Paul on Friday, and I didn't get a clear answer. Maybe you know. So, what about, is there infectious virus in the intestine, and I didn't get a clear answer. In this in the manuscript, Evolution of Antibody Immunity, I mean, is it correct? You find viral RNA in the intestine, and you're suggesting that it's persistent, may be involved with the memory B cell persistence. Is that what I'm understanding?
Yes, that's correct, and that's really the work of Saurabh Mahandru at Mount Sinai. So he's a gastroenterologist, and he spends a fair fraction of his time with endoscopes taking samples from individuals' intestines, and it's pretty clear that 3 months or so after people have had their few week encounter with SARS-CoV-2, he can find antigen positive cells in the gut epithelia. It's patchy and it's not uniform and it's not everybody, but he could certainly find RNA, certainly find antigen positive cells. And Pamela Bjorkman looked in the EM and could find viral particles. The final version of the paper doesn't contain those pictures because there was some back and forth between Pamela and the reviewer always gets the last word. So those images didn't make it into the final version of the paper. But Pamela's pretty experienced at looking at these things, and she thinks she can see virions. It's certainly not routinely done, and that there have been correspondingly few reports of it. I mean, the lumen of the gut's a pretty hostile environment. It's not really conducive to finding infectious virus, but that in no way says that the gut lining isn't infected.
Right.
We know there's a ton of HIV in gut lymphoid tissue, but good luck trying to isolate HIV from stool. It's it's just not straightforward.
1 week later.
Friday. And I didn't get a clear answer. Maybe you know.
I guess the thought from that is that how would these viral fragments remain around for that long? Right?
If they're not replicated.
We chew up everything, don't we? They would have to be very highly resistant to degradation or protected by some other mechanism. And so otherwise, it's hard to imagine. I'm not saying there is replication-competent virus, but and I'm just questioning, how could we retain those fragments around for 6 months?
So we don't know longer, right? That's as far as we can go.
For now, yes. We are gonna this is an ongoing project. So we're about to get the cohort back for the 1 year visit. So we'll follow them to see what happens over time, obviously, because this is, I think, an interesting question.